Hello everyone. Let's do some examples with circles. The first example, we need to tell whether the line, ray, or segment is best described as a radius, chord, diameter, secant, or tangent of circle C. So here we have circle C with the center is C, therefore the name. So we want to know, what is line segment AC in this circle? Well, AC, A is a point in the circumference and it extends to the center. Therefore, this is called a radius. AB, line segment AB goes from a point in the circumference through the center to an opposite point in the circumference. Therefore, this is called a diameter. Now let's take a look at ray DE. So ray DE is on the exterior of the circle and it goes and touches the circle at point B and it extends past it, but it does not intersect into the circle. So therefore, DE is a tangent. Now line AE does go through the circle at point A and comes out at point G. Therefore, this is called a secant. Now we need to figure out if we can figure out the radius and the diameter of these circles that are on a Cartesian plane. So circles A, B, C, and D are all coplanar circles. Let's take a look at circle A. The radius of circle A, well, we can count the boxes and then determine what the scale is. The scale is 1 by 1 on the x and y axes. Therefore, the radius of circle A is 3 units, and the diameter is just twice the radius. So that should be 6. 1, 2, 3, 4, 5, 6. Okay, let's take a look at circle B. Notice the circle B is not touching the x-axis or the y-axis. But since we know the scale is 1 unit per box, we can say here's circle B, here's the center, and we can count 1 and 2 units. So the radius is 2 and the diameter is just going to be 4. Theorem. In a plane, a line is tangent if and only if the line is blank to a radius of the circle at its endpoint on the circle. So let's take a look at this figure. We have a circle with a radius and it intersects line M at point P. And if we look at this box, it's telling me that it's forming a right angle. Therefore, we know that that must be perpendicular. So the tangent has to be perpendicular to the radius. So line M is tangent to circle Q if and only if line M is perpendicular to QP, line segment QP. Now let's take a look at this example that follows the theorem. In the diagram, line segment PT is a radius of circle P. Is line segment ST tangent to circle P? Well, what do we know? If we do have a tangent here at ST, then ST must be perpendicular to TP. If we have a perpendicular line, then we know that we would form a right angle, and STP is a triangle. So we're trying to figure out if we have a right triangle. What do we know about right triangles? Well, we know that the legs of the right triangle, the square of the sum of the legs, has to be equal to the hypotenuse squared. And that is the Pythagorean theorem. So let's use the Pythagorean theorem. 35 squared plus 12 squared. Is that equal to 37 squared? The answer is 1,225 plus 144 is in fact equal to 1,369. Therefore, ST has to be perpendicular to TP.